this video, I'm going to explain the difference between recursive equations that show a pattern of what's going to happen next, and explicit equations, a pattern that will help me find any future value. So recursive equations have the first part always looks the same. It always starts with f of n equals f of n minus 1. And what it's saying is f of n means the one I'm looking for now. That's what f of n means. So to find that, you take the previous term, which is the one we just had, and you do some action. And so the other second part of a recursive equation is the starting input and the starting output. So I have two examples below, and I'm going to use color to help you find those values. So the first thing I notice in this table is that the starting input is 0 and the starting output is 7. So those numbers I'm going to put in my formula to say, hey, for this pattern, f of 0 equals 7. 7 was my starting output. 0 was my starting input. So that's the first part of your recursive equation. It's just telling the person who's reading it where your table starts. So at 0, it's 7. And then if we start to look at this pattern, we say, hey, from 7 to 10, that is adding 3. From 10 to 13, that's adding 3. From 13 to 16, that's adding 3. 16 to 19, adding 3. This is my action. Every time I'm going to add 3, plus 3, plus 3, plus 3. So now I have all I need to write my recursive function, which would be to find the new number. I'm going to take the one we had before, and I'm going to add 3. This is your, actually all of this is your recursive equation. So that's what it looks like for this first example. Let's do a second example. Starting input in this table is 1. And the starting output in this table is 2. So we always start by saying f of input equals output. So that's saying this table at 1 of an input, there's an output of 2. And then we got to look for the pattern. What's the action? So from 2 to 6, I could add 4, but if I added 4 to 6 again, that would get me to 10, not 18. So this one isn't adding. So maybe from 2 to 6, it's multiplying by 3. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. So this is a geometric pattern because the action here is multiplication. So if I'm going to write my recursive equation, I'm going to say to get to the new value, I'm going to take the value I had before and I'm going to multiply it by 3. That action is multiply by 3. And this is a recursive equation. It's basically saying starting at 1, it's 2. And then I always just copy and paste. F of n equals f of n minus 1, action. That's a recursive. So the cool thing about recursive and explicit is that they require the same 3 pieces of information. I need a starting input, a starting output, and an action. And if I have those 3 items, I can write both a recursive and an explicit. So here are some notes on an arithmetic. They are a teeny bit different. I hope you're seeing they both have yellow, red, and pink. Yellow, red, and pink. But in an arithmetic, the pink and the n are big. They're showing multiplication. But in a geometric, the n and the pink are exponents. They're small. So that is the one major difference between the two. So I've copied the same exact tables, and we're going to use those as an example. For an explicit, it's saying the starting output, the action, and then you multiply that action times n minus the starting input. And that's because an arithmetic sequence shows repeated addition. And when I plus 4, plus 4, plus 4, plus 4, that's really multiplying. So let's do the arithmetic one first. The starting input is 0. Starting output is 7. And the action is plus 3, plus 3, plus 3. And repeated multiplication, or repeated addition, is multiplication. So I'm going to write my expression. F of n means to get any value. I'm going to take 7, because that's where I started. I'm going to do this action of plus 3, and I'm going to do it n, and then I would say minus 0 times, but n minus 0 is just 0, so n times. Actually, I'm going to write that out so you see it, n minus 0. So to simplify that, my expression is f of n equals 7 plus 3n. 7 was my starting output, plus 3 was my action, and then n is my variable. I multiply it by 3 by the number of the input. And my geometric version is, I have a starting input of 1 this time, and I have a starting output of 2. And we just looked at this one. The action was times 3, times 3, times 3. And when you repeatedly multiply times 3, times 3, times 3, that's really exponents. So I'm going to say to get to any value, I'm going to start at 2. I'm going to multiply by 3, that's my action, n minus 1 times. So 2 was my starting input, times 3 was my action, and then this problem has a minus 1 in it because if I wrote this out in the annoying recursive pattern, like let's look at this row, 4 and 54, it would be 4, the fourth input. I would start with 2 and I would multiply 2 times 3 times 3. And so, times 3, sorry. I'm multiplying by 3, n minus 1 times. So since n is 4,